So this will be your 8 mark question. So they have given A value, U value. They have asked you to find V value, basis image, and you have to reconstruct the original image. So reconstruct the original image means you have to find U again. So I thought you yesterday only, like it's V is equal to AU A transpose. So that will be your formula. So what is A? Here it's 1 by root 2 into 1 minus 1. So write down according to the question. So into 1 2 3 4 into 1 by root 2. I told you, like for transpose, you have to write row as column and column as row. So next, what happens? So 1 by root 2 into 1 by root 2, what will it will be there? No, that will be equivalent to 1 by 2. So 1 by 2 into, so this three matrices will be left. So you can directly do the matrix multiplication using calculator. So mat A, mat B, mat C. I thought yesterday how to do that, or else you can directly multiply this two. This two you can multiply the first column and this first row, like 1 into 1 plus 1 into 3 will be 4. So like that you do matrix multiplication. So after that, you for if you multiply this 2, you will be getting this value 4 6 minus 2 minus 2 into 1 1 1 minus 1. So 4 into 1 is 4 minus 6 into 1 will be 10. So you will be getting one matrix, but here half is there. So when you divide it, you will be getting it as 5 minus 1 minus 2, 0. Till here, everyone understood or anyone have doubt how to find V? Vishal, Shreyas, anyone having doubt to find V? Okay. It's very easy, just the matrix multiplication formula, substitute the values, and you will be getting. If you do this much, you will get 3 marks easily because it's a 8 marker. So they will be having some. So to find the basis images, just you have to find out the inner product. So for 0 comma 0, you will be taking 1 and 1, and for so A 0 comma 0, so you will be just finding out 1 comma 1, the first row and the first column. So you will be writing 1 1 1 into 1 1 1. This is nothing but your inner product. So whatever you write in the row, same thing you have to write, or in the column you have to write the same thing in your row also. So half into 1 into 1 into 1. So this will be your first, your A star 0 0, A conjugate 0 0. Now 0 comma 1 means it's a first row, second column you have to take. So 1 by 2 into 1 1 1 1 minus 1. So A star 0 comma 1 will be half into 1 1 minus 1 minus 1. So A star 1 1 means you have to take 1 minus 1, 1 minus 1. So it will be similar. If it's same 0 0 1 1, you have to take the same, like 1 1 minus 1, 1 minus 1. If it's 0 comma 1, you have to take the first row and the second column. So whenever you do, you will be getting A star 1 1 as half into 1 minus 1, 1 minus half into 1 minus 1 minus 1 1. So to find U, what you have to do, this formula you have to use A star transpose into V A star transpose. So whatever A it is there. So A star transpose, whatever A you have got, similarly that only you write here. 1 1 minus 1 1 1 minus 1. So the V is nothing but your image. What you have got image V as 5 minus 2 minus 1 0. That you substitute. So into A star and A star transpose remains the same according to your property. So 1 minus 1. So use your matrix multiplication. See whether you are getting, verify. Are you getting the same answer? 1, 2, 3, 4. Original image. Are you getting back the original image whenever you multiply? Vishal and Shreyas, do you know, right, how to put in Calci the matrices? Vishal, should I teach again? What about Darshan? Do you know how to multiply matrices using calculator? Or else normal also you can find it out. Anything is fine. Darshan, respond. If you don't know, we can teach it. There is nothing wrong. Darshan, Shreyas, did everyone understood this problem? Anyone having doubt? Next, we will be moving on to Kronecker product and dimensionality. So, the dimensionality of image transform, if I have written as IT, its image transform can also be studied on the terms of Kronecker product. So, can you teach second problem again? Which one? Which I have to teach? Basis images, huh? So, see, basis images means you have to find out A star 00, A star 01, A star 11. So, what is, sir, my mic was yours muted. Please unmute my mic. Oh, I have to change. I don't know why I'm changing the settings. Okay, I have unmuted everyone. So see A star 00 you're supposed to find. So A star 00 is nothing but your 1 1. Your it's nothing but 1 1. So A star 00 is nothing but your first row. Whatever A star 00 is there, that will be your first row. This one A star 00 is first row. A star 1 1 will be your second row. This you remember, students. A star 00 is your first row, and this will be your A star 1 1. Okay. So first you have to find A star 00. So A star 00 means it's half into, so it will be, because your A is half, so half into 1 into 1. You have to write in the column first, and then you have to write 1 1 in the row. This is how you are finding your inner product. Inner products, this is a rule how to find out. Did you understood, Vishal? Half into 1 into 1 and 1 into 1. Similarly, you are finding 0 comma 1 means you have to write the first column and then second row, second one in the row format. Understood? In other things, it's just the normal multiplication. See how much irregular people are. See, like, don't neglect module 2. Module 2 is very easy. Only it involves the more equations and all, but this problem directly they will ask you in the examination. It's very easy to get 8 marks. And it was there in our attempt, in your like first attempt what you wrote, it was there, this problem. This might get repeated, so learn the problem, practice it, because it's 8 marker. You can directly get 8 marks along with the cosine transform, sine transform, and properties of 2DFT. Okay, these are the questions which you are supposed to learn. So this Kronecker property is not so much important, but learn the definition. What is a Kronecker product means? It's y is equal to ax, and it's separable when a1 is cross producted with a2. Equation 1 can be reduced as a1 into a2 transpose. So this is how the Kronecker product will be there. Okay. The next one will be your dimensionality of image transform. So the 2n cube computations of V can also be reduced by restricting the choice of A to the fast transform. So this will be having P is equal to log 2 base n operation, dimensionality of the image transform. So they might ask for 1 mark this definitions, if or else not, it's not so important. You can just read the notes, whatever the definitions I have written. So the properties of unitary transforms is very much important. So it will be having, the first property is energy conservation and rotation. So whatever I have written in the notes, same thing you are supposed to write. In the unitary transform, V is equal to AU. So if I have written this double line whole square, means it's the length of that. The length of V the whole square is equal to the length of U the whole square. This can be easily proven by the length of V square is approximately equivalent to K is equal to summation K equal to 0 n minus 1 V of K the whole square is equal to V star transpose into V. So V star transpose is nothing but U star transpose A star transpose into AU. So it's nothing but A star transpose and A you can neglect or else you can omit, which will be equivalent to U star transpose into U. The next comes, the second property will be energy compaction and variances of transform functions. So the most unitary transforms have a tendency to pack a large fraction of average energy of that image into a relatively few components of the transform coefficient. Since the total energy is preserved, this means nu V is approximately equivalent to E of V, which is approximately equivalent to, see, V is nothing but A into U. So I'll be writing E is equal to A into U. I will be taking A as common. So A into E into U, which is equal to A into nu N. So RV is equal to E into V minus nu V into V minus nu V, the whole transpose. A into E into u minus nu v into u minus nu v the whole transpose into A star transpose. See, this is not such important, but then also you start to learn. They might ask or they might not ask. So at least learn. Okay. Now whatever I'm teaching, it's very much important. The two-dimensional DFT, very much important for 10 marks. So they will be asking you to prove two-dimensional DFT and write the properties of two-dimensional DFT. So follow it correctly. So very less topics. See, whatever I will be telling, you are supposed to study from the module 1, module 2, sorry. First, you will be studying definition of image transforms, image basis images. So then you will be studying what you will be studying. You will be studying that derivation. So what derivation? You will be studying that unitary transform and separable unitary transform derivation. Then you will be studying the problems. Whatever I've thought this problem, they might change and give the values. So this problem will be for 8 marks. Then you will be studying the small definitions, whatever I've given, like whichever notes, the 16 pages notes, along with Haar transforms, which I will be sending you on Monday. So if you study this much, it's sufficient from module 2. Don't study anything other than this. Okay, students? Hello?
Ready?
Till here, you're supposed to learn. Okay. So the two-dimensional DFT of an n cross n image, U m of n is a separable transform and it's a defined transform as P of K of L is equal to summation of n minus 1, m is equal to 0 to n minus 1, n is equal to 0, n minus 1, u of m comma n, w n par k of m, w n l par n. This is first equation. Students, I can't help. You are supposed to learn these equations. Write and practice. Then only you will be following. I can't tell you like how to derive these equations. Like there is a method to derive, but that's not there in your syllabus. Just you are supposed to write the equations. Okay. So next, u of m comma n is equal to 1 by n square. So just 2 to 3 times if you write, you will remember this equations. So u of m comma n is equal to 1 by n square into summation of k equal to 0 n minus 1, L is equal to 0 n minus 1. See, for this summation, for V it will be m and n. For U it will be k and L. Okay. So for V, it will be always your object. For your for the original this one, it you like reconstruction, you will be writing your image. That much you can remember and you can relate it and write your equations. So V of k comma L into Wn whole minus km into Wn minus ln. So that will be your second equation. So the two-dimensional unitary discrete Fourier transform pair is defined as. So next, this will be your third equation. So it will be 1 by n into. So summation m is equal to 0 n minus 1 u of m comma n wn km wn ln. See, if you learn first equation, your third equation becomes easy. Just you are supposed to write 1 by n extra, that's it. Hello, are you finding the trick here? If you learn your first equation, your third equation is nothing but 1 by n you are supposed to write. Okay, student? If you have learned the second equation, so the only change what you will be doing is you will be writing 1 by n over here. Other things will remain same. Are you able to see, relate, understand? If you learn these two equations properly, your third and fourth equation becomes easy. So just you will be writing 1 by n and 1 by n after that. Okay, students, are you able to understand? Okay. So this is your two-dimensional DFT. So V is equal to FUF. So V is equal to FUF. So U is equal to F star V F star. So if this will be your equation 6. So I think two-dimensional DFT will be easier if they ask you to write about two-dimensional DFT and explain its properties. You are supposed to write the 6 equations and write the properties, students. So the first property of this is 100% sure question, students. This is 100% sure. Definitely, you will be having in your examination. Without this, they won't set the paper only. So, the properties of two-dimensional DFT is the first property is symmetric unitary. Now, only write down. I am giving you time to write down. Don't just see like cinema hall, like cinema is going on. Like don't see. You have to write and practice. So one day I'm going slowly. Write down the first property, symmetric unitary. The first one will be F transpose is equal to F. Wait, students. F inverse is equal to F star. F star is cross producted with F star. In this Bangalore, no, like mornings and all, it will be full, full sunny, and in night times it will start to rain. What I don't know, from past 2 to 3 days, the same situation happening in Bangalore. Anyone is there in Bangalore? Where all of you reside? Aryan, where will you live? Belgaum or somewhere? Okay. You, Bangalore, which place? Oh, all are from Bangalore only. Okay, okay. I thought many people are from Belgaum, Chitradurga, and all. Like many people had joined. HAL. Okay, Mysore. Okay, okay. Shreyas R is also from Mysore. Okay. Mysore is very near, only 3 hours. So write down these three properties. So you're all supporters of RCBs or CSK, all of you. Like there will be many people supporting all four are RCB only. Huh? But this rain should not come right today. If rain comes, they will give one point and abandon the match. I have given time to write down these three properties. Later, I will explain. Everyone write down because this is 100% fixed question. So only I'm giving you time to write down. After finishing, tell me that I will explain these three properties. Like, let's pray that it won't rain today. The first property is symmetric unity. So F transpose is equal to F. F inverse is equal to F star. So F star is complex conjugate with F star. So that will be your first property. So the periodic existence is nothing but V of K plus N comma L plus N, which is equal to V of K comma L. So U of M plus N comma N plus N, which is equivalent to U of M comma N. Students here, none of you attended the interviews and all. Aryan, Darshan, Shreyas, Vishal. You didn't attend any interviews as of now? Any companies? No, How many, like, see, you have to be very much bold enough. Whenever you're attending your interview, your English should be very good, fluent. Like, no need of foreign English. At least good, fluent English will be mattering a lot. So learn it. Be bold enough. I see like many people are afraid to talk with me only, as if 1,000 people are there next to you. There will be hundreds of people. You are supposed to talk in front of them without any shy and hesitation. So if you are very much shy and hesitated, so you are like you will be rejected. So I hope so. Everyone clear all your backs. Many people have many backs. So focus on your studies. You know when is your examination. So like I'm not going very slowly, like one module, 10 days, 15 days. If I do, I can't complete the syllabus on time. So like I'm teaching you in the proper speed what's required so that you can score at least 60 to 70 range marks. Okay, at that level, I'm making you to prepare. So I can go very slowly. Module one, okay, one question also I can take and like I can draw the diagrams and explain slowly. So if that happens, like I can't do any other modules. So still three is like still one first module only have left to distance measures. I will be doing on Monday like distance measures and hard transform. If I take like within 40 minutes, I can complete that. So module one and two will be completed by Monday. So next module three we will be starting from Tuesday. So I will try to complete module three and first half of your module four within Saturday, like taking 2 hours, or else I will complete module 4 within Saturday. And Monday, Tuesday, we will see on fifth module. Fifth module is very easy, like just noise models, all its base theory and small derivations is there. So that will complete your fifth module. Like fifth module doesn't take time. Like fourth module is little bit lengthy. I have to explain about the filters and all. RGB color model, CMYK. Do you remember, students? Or else forgotten? Fourth module, RGB model, CMYK model. What is RGB? What is RGB? RGB model, red, green, blue. CMYK is cyan, magenta, yellow. K means, what is K? K means black. Very good, Aryan. So you are good. So keep on revising whichever modules you know. Did everyone finish this three? So sampled Fourier transform is u bar is equal to 2 pi k by n, comma 2 pi l divided by n. DFT is equal to u of m comma n, which is equivalent to v of k comma l. So this is just equation. Next, fast transform. Write down. Like I'm giving time to write because this is fixed 8 or 10 marks question. Properties of two-dimensional DFT. Only if you write, you will be able to understand. Since the two-dimensional DFT is separable, the transform is equivalent to 2n one-dimensional unitary DFT, each of which can be performed O log to a base log to n operations, and hence total number of transformations is O n square log to base n. So write down RGB color model, CM by K, pseudo color image processing. So intensity level splicing you will be having, and you will be learning about those filters, low pass filters, high pass filters, and homomorphic filtering. Do you remember at least the topic, students? At least not the contents. At least this and all is there in module 4. Do you remember or else forgotten? Homomorphic filtering, Laplacian one. So that only that much is there in module 4. So in module 3, you will be having the histogram processing, local histogram processing, and you will be having this one. Uh, that what is that? Species one. That graph you will be having logarithmic, those things. So, and problems like local histogram and histogram processing, they are giving for 10 marks. It's direct, it's very easy. Histogram processing. I will teach you, like there are three kinds of problems what they ask in the examination. Like we will go slowly. One, like I will be teaching you that. So like be live, like whenever I mention attend the live class, there is like you have to, you will get benefited from the live class only more than the recorded session. So be attending the live session. The next one will be conjugate symmetry. So what happens in conjugate symmetry? The DFT and unitary DFT of a real images exhibit the conjugate property. So V of n by 2 plus or minus k, n by 2 plus or minus L is equal to V star of n by 2 plus or minus k, n by 2 plus or minus L. So this, students, you can write down later basis images. So basis images is A star KL is equal to 5K. I have shared the notes. Write down and practice now only dimensional DFT. So there are 7 properties. So if you write 7 properties, you will get complete 10 marks. Okay, students, you will be getting complete 10 marks. Okay, so this will be your basis images. So next, for a circular convolution, this is formula u2 of m comma n is equal to summation of n minus 1, m dash is equal to 0, n minus 1 is equal to n dash is equal to 0, h of m minus dash. So this is just the diagram which you have to remember and write. Okay, you write down this is just a properties what you are supposed to learn. So cosine transform. The next one will be your cosine transform. So the two-dimensional circular convolution theorem, just draw like how it will be looking this blocks. It will be like modulo n and n modulo n. So it will be k. So this block will be getting separated whenever you do h of m comma n is equal to 0. You will be using m minus n transforms. So this three diagrams you write cleanly. So this will be for your dimensional two-dimensional circular convolution theorem. Students, like today, I will be taking only one session because I have some work. The other next session, I will plan to take tomorrow, or else I will take Monday one. Okay. Just a cosine transform is left. Cosine and Haar transform is left. So this cosine and Haar transform, you can, I will teach you by taking two sessions on Monday only. That will be sufficient, I feel. So module 2 will complete by Monday. So what's your work today is from module 1, digital image processing. You're supposed to learn origin of DIP, applications of DIP. This third question, what you have to do, you have to learn about the components of DIP, steps in digital image processing. So image formation in eye, structure of eye, and you have to learn image acquisition. So in image acquisition there are three types. Can anyone tell what are those three types? Unmute your mic and tell, because it's just 1 minute time. Vishal, will you tell? Sensor strip, array. So sensor strip, array, and this one line sensor you will be having. Okay. So that, and you have to learn about sampling and quantization. So next, the distance measures I will teach you later. And whatever the concepts I thought till two-dimensional DFT, you are supposed to learn Sunday till Sunday, you have to learn this concepts and come. So another